In this video, we are going to learn about free body diagrams, FBD, and we are going to learn the steps that we must follow to solve problems on Newton's laws. So what is a free body diagram? In a free body diagram, a sketch of the body is drawn and all the forces acting on it are shown. Other bodies and supports are not shown. The direction of acceleration is also shown. So suppose we have a problem like this. A mass M is resting on a table and somebody is applying some force F here. The weight will be acting down. The normal reaction will act perpendicular to surface and friction will act like this. Now when we show all these forces only and we show the direction of acceleration, it is called free body diagram. We don't show supports, other objects. When you are drawing the free body diagram of M, look only at M. Let us look at a simple Atwood machine that we discussed earlier. So this is a pulley here, mass M1 here, M2 here. Now we want to draw free body diagram of M1. So we draw M1. Anything having mass, weight will act vertically downwards. So this is having mass, weight acts vertically downwards. Now it is not resting on any surface, so there is no normal reaction. Anything connected by a string, tension will act along the string away from the body. There is no other force acting on M1. If we assume M2 is more than M1, then M2 will accelerate down, M1 will accelerate up. Therefore, acceleration of M1 is upwards. Please understand this. When we are drawing free body diagram of M1, we are not looking at anything else. When you are drawing free body diagram of M1, just look here. Don't look here, anywhere else. That is very important, remember. Now let's draw free body diagram of M2. So M2 is here. Again M2 is having mass. So M2G will act vertically downwards. Is connected by a string. Tension will act along the string away from the body. And the acceleration is downwards. There is no surface, no normal reaction. Always look at forces systematically so that you don't miss out any force. Now let us look at the free body diagram of pulley. This is the pulley. Pulley is connected by string up. So there will be tension acting upwards. There is a different string, so different tension. But these two are part of the same string here. So again here tension will be acting down. Tension will be acting down. This pulley does not have mass, so weight is not there. This is how we draw free body diagram. We draw a sketch of the body, draw all the forces acting on the body, show the direction of acceleration and don't show other objects. Now, for applying Newton's laws to solve problems, we will always draw free body diagrams. So what are the steps in solving problems on Newton's laws? First step, always draw the diagram. If the diagram is given, very good. If the diagram is not given, draw the diagram. After drawing the diagram, fix a consistent direction of acceleration. The direction may be wrong, but it must be consistent. Let me explain this to you. If this is that same Atwood machine, and here is M1, and here is M2, and let's say again M2 is more than M1, it's very obvious this will accelerate down, and this will accelerate up. So this is the correct direction of acceleration, is consistent also. But suppose someone by mistake assigns opposite direction of acceleration to both the objects. So he doesn't realize that M2 is more massive than M1. He says M1 will accelerate down and M2 will accelerate up. He is incorrect, but he is consistent. So he will be able to get the answer. A will come out to be negative. So problem will get solved correctly. But suppose someone says that both the objects, both M1 and M2 will accelerate downwards. That is not possible because the string in that case will break. Right? So this is inconsistent and he will not be able to solve this question. Suppose he says both are accelerating upwards. That also is not possible because of this string constraint. We learn string constraint as we go along. That also will not help in solving the problem. So we must fix a consistent direction of acceleration. The direction may be wrong, but it must be consistent. After we have drawn the free body diagram, we will apply Newton's second law. F net equal to mass into acceleration. That will happen in one-dimensional case. Suppose it is a two-dimensional case, then we resolve forces in the direction of acceleration and perpendicular to acceleration. This trick you remember because these books will not tell you, teachers will not tell you, but this you must understand that in every problem we must resolve forces in the direction of acceleration and perpendicular to acceleration. Then along each axis we apply F net equal to mass into acceleration. Once you have got these equations, we solve for acceleration and tension simultaneously. And this is how we solve problems on Newton's laws. Let us first look at this simple etude machine. Simple etude machine is really simple. Here we have got a pulley, here we have got M1 and here we have got M2. Say M2 is more than M1. It makes no difference, we can take anything that's more massive. If M2 is more than M1, obviously M2 will accelerate down and M1 will accelerate up. Remember, the first step is to fix a consistent direction of acceleration. Once you have done this, we will draw a free body diagram of M1. Whenever you are drawing free body diagram, first check if the body is having mass. If it is having mass, weight will act vertically downwards, M1g. Then check if the body is resting on a surface. Normal will act perpendicular to surface. This body is not resting on a surface, so there is no question of normal reaction. Third check, if the body is connected by a string that is tight, then tension will act along the string, away from the body under consideration. So tension acts this way. And the acceleration is upwards. Now how do we apply Newton's second law? F net is equal to mass into acceleration. So here this force has to be more than this. Why? Because the acceleration is upwards. Acceleration is always in the direction of more force. So net force is this minus this. This is the net force in the direction of acceleration. So F net is mass into acceleration. This is what is Newton's second law. Here F net is T minus M1g. Be careful about the sign, right? Whichever direction acceleration is here, that direction force is more. So T minus M1g is the net force. This will be equal to mass into acceleration. This is equation 1. Now let us look at M2. What are the forces acting on M2? Again M2 is having mass. So first force we'll draw is the weight. acting vertically downwards, m2g. Remember, weight always acts vertically downwards towards the center of the earth. Again, m2 is not resting on a surface, no question of normal reaction. m2 is connected by a string that is tight. A tension will act away from m2 along the string. Now the acceleration of m2 is downwards. So therefore downward force is more than upward force. Net force will therefore be m2g minus t, and that is mass into acceleration. This is our second equation. Now in most cases, if you add the equations, tension will cancel out. Tension will vanish. So let's add equation 1 and 2. You see plus t minus t, they cancel each other. So adding 1 and 2, what do you get? m2 minus m1g equal to m1 plus m2 into a. And from this equation we get the equation for acceleration, which is m2 minus m1g by m1 plus m2. Very simple. Now we can get tension from any equation, whichever equation you like, equation 1 or equation 2. Let's take equation 1. What will tension become? This will go that side. So tension will become m1 a plus g. What is A? A is here, you already found out. So what do you get? m2 minus m1 by m1 plus m2 into g plus g. Now if you simplify, m1g and m1g will cancel. m2g and m2g will get added up. So finally we will get the formula for tension 2m1 m2 g by m1 plus m2. This is how we apply Newton's laws to solve problems. Now we'll take up one more problem on Newton's laws. This is a table. There's a pulley here. Mass m2 say is hanging here. m1 is lying on the table. First question, what is the direction of acceleration here? Whatever be the mass of m1, m2 will always be able to pull m1 down because there is no friction here. Now we are solving problems where there is no friction. So m2 will always accelerate down. m1 will accelerate this way. Think on this. Two perpendicular forces never affect each other. Weight of this will always get balanced by normal reaction. This tension is acting in this direction. So this is only acting against the frictional force. And if there is no friction, this string will always be able to pull m1 that way. Two perpendicular forces don't affect each other directly. This is very important to understand. When a car breaks down, the driver comes out of the car and he is able to push the car because he is applying a force perpendicular to the weight of the car, and friction between the wheels and the ground is less. The motor weight is rolling friction, so car rolls forward. A bunch of people can push a truck. All this is because the applied force is perpendicular to the weight. People are able to pull trains, planes with their teeth or hair. That is because they apply a force perpendicular to weight. Ask them to lift the car or lift a truck, they cannot do that. So please understand that this mass will be able to accelerate this down, whatever be the masses of m1 and m2. So this is the direction of acceleration. Now first let's draw free body diagram of M1. What are the forces acting on M1? M1 is having mass, so weight will act down, vertically downwards towards center of earth. M1 is resting on a surface, so surface will push that up with a force that we call normal reaction. M1 is also connected by a string. The string will pull that, and that force is tension. And the acceleration is in the direction of tension. Please understand, we are not bothered about the vertical forces now. So look only at the horizontal force, tension. And tension is the net force, there is no other force. So tension will be equal to mass into acceleration. And this is our equation 1. Right? Now let us look at M2. What are the forces acting on M2? M2 is having mass. Right? The earth will pull it down. So therefore, the weight will act vertically downwards. M2 is not resting on a surface. Right? Nothing is below M2. So no normal reaction. But M2 is connected by a string. So tension will act away from M2 along the string. That is the property of tension. And the acceleration is downwards. So acceleration is downwards, so net force must be downwards. M2G must be more than tension. So M2G minus T is the net force in the direction of acceleration, and that will be equal to M2 into A. Let's call this equation number 2. Again, if you add the two equations, tension will vanish. Right? Tension gets killed. So you are left with M2G only if you add the two equations. And what is there on the right hand side? M1 plus M2 into A. So in this case, acceleration is M2G by M1 plus M2. Right? And once you found acceleration, tension is very easy. Right? T equal to M1A. So what will be tension? Tension will be M1 M2G by M1 plus M2. Right? So this is how we solve this simple problem. Remember, if you think logically and go step by step, then you will always be getting the correct answer. Important thing is to look at the forces systematically. First see whether the body is having mass. If it is having mass, weight acts vertically downwards. Next, check whether the body is resting against any surface. Then normal reaction will act perpendicular to the surface. Next, check if the body is connected by a string. Then tension will act along the string, away from the body under consideration. If the surface is rough, friction forces may also act. But if you think logically, you will always get the correct answer. Acceleration is always in the direction of more force. So if acceleration is downwards, the downward force is more than the upward force. So net force will be downward force minus upward force. If the acceleration is upward, net force is upward force minus downward force. So this is how we apply Newton's laws to simple problems. Right? It's very, very simple. Just think systematically, go logically, solve step by step.